There's probably not another undergraduate senior in college that gets this kind of experience, even at MIT or Ohio State or some of these massive schools that have amazing amount of research funding. We're at the United States Air Force Academy. The Department of Aeronautics here is definitely the most well-equipped aeronautics lab in the country, especially at the undergraduate level. We have multiple levels of wind tunnels. We have amazing manufacturing capability. We take cadets through their full aeronautics major, and in the end, their goal is to design, build, and fly an airplane in a very short turnaround time. The only way we do it with the level of precision and accuracy that we do it today is because 3D printing has infected it so much. We used to get 3 or 4, maybe 5 airplanes built a semester. Maybe 2 or 3 of them would fly, maybe. Now we have the capacity to build lots of airplanes, so typically we're building 8 or 10, 12 airplanes per semester. And why can we do that? It's because we have the design tools and the manufacturing tools to do it.
Part of the learning process that our students go through is failure. And inevitably, when they're creating an aircraft, something will happen and the aircraft will crash or be damaged in some way. And that's where 3D printing really has an advantage for us, because if we have an aircraft crash, we can come back and the part that's broken, we can put it on the printer, and we come in the next morning, we'll have the replacement part that we need so we can try to fly again. Whereas if we were to try to construct it by hand out of balsa wood, it would take a lot of manual labor. With 3D printing, we have a repeatable process that is hands-off, where we can manufacture the replacement parts we need on an as-needed basis. We don't need to do a large bulk order of parts in advance. We can print new parts to repair the aircraft as accidents happen.
One of the beauties of having a 3D printer is I can get a part at 2 in the afternoon, I can slice it, get it on the printer, it can print all night, and then by the time the students come back the next day, they have a part in their hand. That's the way the world works today, and that's what we should be showing them. When you design an airplane, it's built on a computer screen somewhere, and we're going to take that CAD drawing and turn it into a real airplane. So it suddenly jumps off the screen, and now they're holding a real piece. And the fact that we can do that quickly with a 3D printer is amazing. They really get excited by the fact that they handed me a file one night, and the next day they're holding the piece that they're going to put on their airplane.
It really makes the world come alive for them. You just see it on the students' faces. It's an indescribable feeling where all of their 4 years has come together to reward them with this moment where they've actually made an aircraft and flown it. So it's really a special feeling for them.
When it goes airborne and it flies around for 5 or 10 minutes, the whole learning loop is closed. They go, wow, I really do understand how an airplane flies, I understand how it works, and I also understand that even at this small scale, these things are very complex. And so when you translate that to the real airplane that they're going to go jump in, it gives them a great appreciation for how those things operate and the complexities that they inherently have inside of them. We take big risks because we want great return, and we're willing to take those risks to give the cadets the best experience that they are supposed to get at the Air Force Academy. And that is exciting to me.